And we have Sandy Kidd with us. Sandy, welcome, sir. You know what? Look, before you get started, let me read your bio. Sandy Kidd is a Scottish inventor and former RAF radar technician who developed a novel approach to gyroscopic propulsion in the 1980s, based on the principle that a gyroscope set at various angles could provide a lifting force. His work has been described as being based on the principle of forced precessed gyroscopes and has been reviewed by Eric Laithwaite, David Hatcher Childress, Dr. Harold Aspden, Dr. Bill Ferrier, and many others. So Sandy, welcome, sir. And take it away.
Hello, everyone. And thank you very much for your kind invitation allowing me to address this conference. My name is Sandy Kidd. I'm nearly 84 years old now and have been hunting down anti-gravity for many of these years. This for me has been a very lengthy hunt in this quest, so I shall air my rather extended story one salient piece at a time. Many times during this quest, I've been asked, why did I do it that way? On the face, it's a very reasonable question. I had visualized turning some easily generated centrifugal force in an upwards direction, and the generally held belief pertaining to the conservation law that this was possible using gyroscopes. However, during continued development, it was found that the reasons for the operation of my devices got further and further away from the original thinking. I have consequently learned many strange things about gyroscopes and flywheels. That said, I was in a quandary as to where to make a start. I have therefore decided to highlight anything I think may be of interest to the conference.
And I can help with, oh, okay, there you go. Wonderful.
Right, Tim, thank you. I must say at this time that my relationship with gyroscopes and inertial drive has now endured for many years, was the result of seriously flawed thinking mixed with success born out of sheer good luck. I started off, I was thinking all weird things at the time, but I had an idea that back in the 70s, I gave a bit of thought to create a device which could divert some momentum in an upward direction. I had the notion that a person could rotate a couple of bricks, one each from a string on each hand, say about 6 inches from the center of the person to the center of the mass of the brick. We must assume that this person has the ability to make himself rotate rapidly around the same spot on the ground or turntable, such that the person can generate copious amounts of centrifugal force via the accelerated bricks in this system. If we consider each brick weighs about a couple of pounds, which would relate to approximately 300 pounds of centrifugal force generated by each brick if the person could rotate at 300 revs per minute. However, no matter how fast these bricks could be rotated by the person, these bricks could never reach the horizontal position, a line, say, through the person's shoulders, because of the effects of gravity. I thought to myself that somehow, by some magical force, rocket motors, of course, were disallowed, and those bricks could be made to rotate at the same speed, but at the angle of 45 degrees of inclination to the horizontal. That would do it. This was impossible, but if these bricks could be somehow raised to this angle, the vertical components would be equal to the horizontal components, assuming that the radii of rotation were the same. Consider 600 pounds of vertical acceleration with a man in bricks weighing, say, 200 pounds, a big man. That would be around 3 Gs of vertical acceleration. Unfortunately, it was all impossible, an altogether fruitless idea. After seeing the 1974 Christmas lectures presented by Professor Eric Laithwaite, when he accelerated a 50-pound flywheel effortlessly around his body and head, I immediately started designing a device to incorporate a pair of gyroscopes into my bricks on strings idea. I hoped that the gyroscopes would be driven fast enough in machine rotation to create the level of centrifugal force I required, and the gyroscopes themselves would rotate fast enough to carry up to 45 degrees or thereabouts to give me the vertical thrust. Such was my knowledge of gyroscopes at the time. Eventually, after a great deal of trial and error, a set of dimensions were finalized. Expediency was always the name of the game. I have abbreviated this very extensive story at this time to get through this part of the saga quickly. The first problem was that the input drive to the gyroscopes had to be on the center line of the vertical rotation axis of the device and had to drive the gyroscope from outside the machine. As I'd already decided to rotate the machine itself by means of my pedestal drill, the input for the gyroscopes had to be at the lower end of the machine. In order that the gyroscopes rotate in opposite directions, I decided to make a bevel gearbox to handle this function, although unfortunately I could only find a pair of matched brass bevel gears from the tuner of an old valve radio. Belt drive from the gearbox to the gyroscopes had already been decided upon, which meant that the output shaft would carry a driving pulley and a driven pulley. The driven pulley would have to freewheel against the direction of the driven gearbox shaft. The engine delivered over 1 brake horsepower at about 14,000 revs per minute, which was ideal for driving my gyroscopes. I thought it would be easier to run the rotation speed of the machine at a fixed speed and, if necessary, work from there. I had a pillar drill available to fill this need, so it was set up to support the top end of the machine. The original rotation speed of the device was set at 350 revs. Much later on, the speed was reduced to about 250 revs after being successfully run at that speed on a different make of pillar drill in Newark, Boulder, Colorado. My first attempt at the problem produced, after much trial and error, a very useful device, which eventually became shown on YouTube as Anti-Gravity Machine Part 1 and Anti-Gravity Machine Part 2. Please accept the fact that this was designed to be a human interest story, so a lot of the personal sacrifice info was exaggerated and added to suit. That's the 2 links there. I'm not opening it this time, I'll be here forever. Originally, the device delivered on demand 16 ounces of thrust for 15 to 20 minutes at a time if required, or as long as the engine was fed fuel. It could be controlled by gyroscopic rotation speed to rise or fall, or even be held midway if required. This part is pretty well the documented history of my first machine. The rest of the story has been the struggle for acceptance. It is strange, often funny, how people, including myself, can go through their lives believing things which are totally untrue, which are never ever affected by their beliefs. I remember a teacher explaining to our science class how gas was liquefied. The process which was explained to us seemed to be quite reasonable at the time and was received as gospel. Much later in life, I subjected myself to a considerable amount of embarrassment when I discussed the process with a knowledgeable American friend of mine who just happened to be a gas compression specialist in the offshore oil and gas industry. I was very diplomatically corrected and educated. I often wonder how the rest of the class fared. In light of the fact that most of them were oriented on literary subjects, the truth would probably never ever affect them. One has to ask who taught the teacher. Similarly, over the years, I've noticed there exists misconceptions or misunderstandings relating to physics surrounding aerodynamics and the operation of gyroscopes. And in many cases, these misconceptions and misunderstandings are held by learned people. Only when scrutinized at very close range, by that I mean actual experiment, can the truth ever be known. If a mass is accelerated in a circle, angular momentum and consequently centrifugal force is produced, the quantity of which depends on the weight of the object, the radius of rotation, and the radial rotation speed. At no time in my life was it ever suggested to me that if the weight is rotating whilst being accelerated in the radial path, loss of angular momentum would occur. This undisclosed information caused me a great deal of time, money, and grief. The success of my first machine depended heavily on the fact that this was not the case. In any event, whilst my first machine was being stonewalled in Dundee University, I went ahead and built a rather expensive second machine, which I thought would perform much better than the first one. This was an updated but very similar device, incorporating many improvements over the original. I will apologize at this point that there is no photograph of this device available, which is unfortunate, as I learned more from this device than any other one. I will be able to rake up some drawings if I look hard enough. However, it is in many respects similar to the Australian laboratory test device, but it had no cams actuating the gyroscopes in and outs. In other words, just a plain machine. I had not considered the use of cams at all at this time. When testing my original machine, I was aware that something was amiss. The copious amounts of centrifugal force which should have been apparent was not in evidence. The alarm bell should have started ringing then. I commenced to test a newer machine and a whole range of unexpected issues were thrown up. In light of the fact it was built so much better than the original, the gyroscopes lifted themselves incredibly easy to a position just as high as the structure of the device would allow. I thought at the time that this was very good. There appeared to be no lifting force or vertical thrust at all. This baffled me. Raising a 1 pound weight, rotated at 6-inch radius at 300 plus revolutions per minute, past an elevated angle of 60 degrees and more, should have driven it through the garage roof. Something was fundamentally wrong here, and I didn't have a clue what it was. I had managed to get 16 inches of thrust out of the first machine, and it just didn't have the ability to do what the newer one could do. In my diary, which I used to keep, I've written that something appeared to terminate the ability of the gyroscopes and supporting arms of the original machine from climbing any higher. What this could be, I did not know. I tried several pathetic mechanical modifications to exert some kind of control, but this was found to be a wasted effort. I just could not stop the gyroscope accelerating inwards towards the center of the device. As the gyroscopes went through this motion, the machine rotation speeded up and the machine apparently unloaded itself. Gyroscopes often appear to have minds of their own, but this was something completely different. It seemed sensible to me to accelerate the gyroscopes in hub rotation to increase the rotation speed of the device. This would drive them out again as the centrifugal force increased. This approach seemed reasonable to me at the time. The next month was spent building a little twin-cylinder hydraulic pump to fit onto the main drive of the device. The pump was set such that as soon as the pump detected any inward movement of a gyroscope, the pump would no longer allow oil to pass and create a hydraulic lock. The pump was designed and set to slip under normal circumstances 250 revs. When gyroscopic movement was detected, a very precise rotary valve was designed to close rapidly, increasing the rotation speed instantly to 500 revs per minute, doubling the speed squares the centrifugal force generated. The expected result was that the gyroscopes would accelerate inwards until the pump stopped the flow. The immediate increase in speed to 500 revs would drive the gyroscopes out again, and so on. When the machine was run up, the system worked very well, apart from the fact I just could not believe the speed at which these gyros accelerated inwards. Instead of slowing the gyroscopes down, the opposite had happened. I sat in the front of that machine for hours watching the motion in total disbelief. Complete confusion now set into my mind. Why the first machine operated so successfully when the second one, much more powerful, much more efficient, much better constructed machine, failed so miserably, caused me a great deal of anxiety and caused me to spend many successive years of my life clutching at straws. My first thought was that there had to be some sort of cyclic motion take place within the first device to allow it to work, although there appeared to be no such action visibly taking place. I was, however, convinced that this had to be the case and examined what I thought at the time were all the possibilities that could allow this action to take place. In the end, I just don't know enough about idiosyncrasies and gyroscope behavior, but I was learning. Excuse me. From that, a bonus from the above testing was finding the elements which were necessary to create what later became known as the pre-launch scenario. Consider a system such as previously described and let it be rotated at constant speed. Let the gyroscopes be elevated to their highest position. From experiment, we know that there is no reaction during this motion. The device is still rotated at the same constant speed. We mechanically arrange to hold the gyroscopes temporarily in this position. We then slow the gyroscopes right down, or better still break them to almost stopping, eddy current breaking perhaps. We then release the gyroscopes from their elevated position and allow them to descend freely. The angular momentum which was previously removed from the system will return in total when the gyroscopes are stopped. A large vertical pulse will be generated during this return part of the cycle. I admit the gyroscope system will be slow to recover, but if made large enough and designed to include numerous opposing pairs of gyroscopes, and though the craft would unfortunately be space-bound, it would create a much cheaper, much safer and controllable alternative to rocket travel. Australia. About this time, I heard about Scott Strachan's machine. Scott Strachan was a fellow countryman of mine who hailed from the city of my birth, Edinburgh. Must be something in the water. Scott had a patent application number 8803860.9 in the name of John Scott Strachan. He'd apparently got some useful results from a gyroscopic device some time before I did. Scott contacted me shortly after my claims were made known, and we chatted of it. It transpired that Scott had taken his machine to Eric Laithwaite sometime previously to my visit, but Eric Laithwaite never ever told me about Scott's visit and the demonstration of Scott's gyroscopic device. This caused us both some concern, but I carried on regardless. An interesting point was raised by Scott that was that his gyroscopes were physically actuated by use of cams to oscillate his gyroscopes simultaneously up and down. Immediately I thought that my gyroscopes could somehow be being oscillated in a like manner in line with my previous thinking. This was about the time my struggle in Dundee University came to an end, and an Australian business showed considerable interest in my device, offered to fund its development, and accordingly a contract was drawn up. I was given the task of building another device, any other device, even a copy of my first device, which would produce the same effects as my first machine. The decision I made in relation to building a cam actuated device turned out to be a very bad one and sent me off on a 20-year wild goose chase. Needless to say, a cam actuated device was designed and built. In fact, a pair of them were eventually built, one for in-house development and one specifically for a lab test. The machine built for in-house development was a straightforward machine built into a suitable frame and was powered by 2 speed-controlled electric motors. This setup turned out to be very useful, the findings of which were used to determine the operating parameters required for the machine built specifically for the laboratory test. On the other hand, the laboratory test was, for very good reasons, a compromise in many aspects. When deciding on the setup for the device to be tested for inertial thrust in the laboratory, I came to the following conclusions. To reduce weight and mechanical complication, both the gyroscopes and associated machine rotation drives would be from the same source. This was a risky thing to do, but as the operating parameters had been gleaned from the in-house development, but identical device, I believed that this was a risk worth taking. The power source would be a water-cooled miniature 2-stroke engine of 6.5 cubic cc's capacity with a considerable power, 1 brake horsepower at 16,000 hours. Power to the device would be through a tried and tested centrifugal clutch, which I had originally made for my first machine and which I had brought with me to Australia specifically for this test. The idea behind the water-cooled engine was that the complete engine and its power unit to be built into a small closed wooden box. This would help eliminate claims of aerodynamic or other outside interference with the results. There would be 2 water tanks on board, both of light plastic construction, one being a feed tank and the other a catch tank. At the commencement of the test run, water would be released from the feed tank to go through the engine, cooling it, ending up in a slightly larger catch tank. It would also ensure there was no change in the weight during the test runs. The engine exhaust was set up using a long piece of manufactured for the purpose silicon tubing facing slightly upwards, again, to eliminate any claims of exhaust gas thrust influencing results. Power transmission was via gears to the main machine rotating drive and a gyroscope rotating power via Bellwood gearbox and pulley drive to the gyroscope. Belts were 6mm round section polyurethane. The enclosed box was suspended in the laboratory on a Kevlar cord via strain gauges from an overhead beam. Unfortunately, this time I had not used radio to control my machines, and to some extent, this limited the machine's capability to produce thrust. This test is described over many detailed pages in my book Beyond 2001. Once again, Lady Luck smiled upon me as the device achieved 20 consecutive and successful runs of non-zero bias. The thrust was not of a large order, but was consistent and definite. Although subsequently deliberately ignored, this represented the first official ever test at which proved that inertial drive was possible and has ever been achieved. Now, later on, Thompson and I were in the process of writing a book, more of a human interest story than a technical description of inertial drive, and the success of the book depended very heavily on the outcome of the laboratory testing. I had previously made it clear that the book would not go into print unless the aforementioned series of laboratory tests were conclusive and positive. The series of tests were carried out under the instruction and supervision of APEC Laboratories, Port Melbourne, Victoria, Australia, probably the highest profile laboratory in the Southern Hemisphere. Against while the device was tested in the APEC laboratories showing positive results, the operation of the device posed more questions than answers as to its mode of operation. There again was something going on which I did not fully understand, but which I thought had a fair idea. I thought a differential in angular momentum had to be created during the oscillation of the gyroscopes. Some vagaries of mechanical accelerated. On the way there, this is the sort of stuff I found out. The only cases I know where a gyroscope will appear to float above its horizontal plane of rotation of its own volition are whilst operating in a gravity accelerated system in precession or in a mechanically accelerated system in precession, or what I tend to call saturation. A gyroscope in a gravity accelerated system is one effectively in decay and therefore dropping, while a gyroscope in a mechanically accelerated system is absorbing energy and rising. Contrary to what the clever people say, in either case there is no angular momentum or centrifugal force present, which is really not much good for our use of the inertial drive system, except perhaps in a free lunch scenario. A gyroscope in a mechanically accelerated system with a fixed system rotation speed, or as it's often called hub rotation speed, will show a loss of centrifugal force at the gyroscope if the rotation speed of the gyroscope is increased, and will show an increase in centrifugal force if the rotation speed is reduced. The term hub rotation speed avoids confusion with gyroscope rotation speed. I have avoided using the term angular momentum, which is really more suitable but less easily understood by the average person. Whereas they are both created by the same acceleration, you can't have one without the other, even if they are different animals. It will be realized that if this is true, it casts serious doubts on the credibility of the conservation laws, in this case, the conservation of angular momentum. Centrifugal force will be at maximum when there is no centrifugal gyroscope rotation. However, at the other end of the scale, when the gyroscope rotation speed is sufficiently raised, the gyroscope will reach what is commonly called precession, but what I now for good reason call the saturation point, where and only at this point, centrifugal force has totally disappeared, and the gyroscope will then accelerate inwards and upwards until it is mechanically stopped. If not mechanically halted on such time as the plane of rotation of the gyroscope is at right angles to the axis of the hub rotation, i.e. as far as it can go at the point or the position of least action. At this point, the gyroscope rotation axis and the hub rotation axis effectively become the same, assuming that the machine is a twin opposed gyroscope. When operating below the saturation point, it would be almost impossible to judge them. Sorry about that. Oh, Jesus. When operating, sorry about that. When operating below the saturation point, as there are no visual clues, it would be very hard to know, apart from serious imbalance, if one gyroscope was rotating faster than the other. I have already stated that the point precession starts or the saturation point is reached, there is no further increase of energy into the system, whilst the gyroscope will travel, if possible vertically through 90 degrees without stopping. There is no balance point on the way. The most intriguing thing is that the system will be found to be rotating without acceleration. There is no angular momentum present in the system. There is no centrifugal force present in the system. There's no accelerated mass. What we have is just a vision, something like a holograph of the system magically rotating with no measurable inertia. As far back as 2004, I stated that no mass cannot be accelerated. This is the only occasion I know where gyroscopes or flyways operate in precision, or as I prefer to call it, can actually produce positive results, and that would be in the free lunch scenario. I built a very simple device from spare parts found in my scrap box. Expedience has always been the name of the game, and this device was treated no differently. It was designed to demonstrate the effect that gyroscope rotation speed on their generation of centrifugal force. It would be more appropriate to call it angular momentum, but I'm using centrifugal force, which is more easily understood by folks. The device, as far as I'm concerned, was able to demonstrate that the variation of gyroscopic rotation speed was capable of raising and lowering the gyroscopes against the central bias spring. Unfortunately, I invariably attract the lunatic pitch who are convinced by virtue of their deep knowledge and experience of gyroscope behavior that it was gyroscopic precession which was doing the job. I obviously did a lousy job with my introduction statement. May I apologize for the very noisy screaming gear. I needed a 14-tooth gear. I think the only one I could find was made of steel and not quite the correct tooth shape, but it did the job. That's a link to that. The first publicized inertial drive. During the 50s and 60s, there had been a fair amount of publicity relating to an alleged inertial drive, which was invented by a Norman L. Dean and popularized in American astounding science fiction magazine by the then editor, one John W. Campbell. The device became well known as the Dean machine or the Dean drive and became the subject of much discussion and controversy. The device was probably the first of more publicized anti-gravity machines, of which there have now been thousands. If you check his background, Dean was nobody's fool. In fact, he would appear to have been quite a rather bright individual, but whether his device produced one-way thrust or not has never been proven. Of course, this announcement only served to fuel the fire of determination within me. I suggested many times previously that any action capable of producing inertia must be a cyclic one. The late B. Harry Stein of Dean drive evaluation, amongst many outstanding achievements, made the comment that a successful inertial drive system would be in the form of a device which could be effectively cyclically change itself from one mode of operation to another. In other words, cyclically change itself from one type of machine to another. His words were permanently fixed in my mind. Harry was a great promoter of model rockets and did a great deal of testing of these things. From that interest in Dean drive evaluation came the Stein-Davis ballistics pendulum test. This pendulum test is cheap and easy to set up and test, and lends itself to visually displaying the outcome of the test. Providing the device on test has been designed to move in the horizontal plane, this pendulum test will very easily show if the device is genuine or not, without the need for sophisticated instrumentation. Well, just after the completion of my VIPAC lab test in Melbourne, Australia, I had occasion to contact Harry in Phoenix. He said, Sandy, I've been witness to and suffered every kind of screaming, snarling, and vibrating gizmo for 30 years without a positive result. But I believe it can be done, so please succeed. I think I can spare you the rest, gentlemen. That's a bit. I'm going to the film photographs now. It's stuck here.
Wonderful. And Sandy, do you have photos to show us?
That's what I'm trying to find. I'm an amateur at this.
Oh, no worries, sir. No worries at all. I just wanted to make sure. I found your videos on YouTube also. I can play the anti-gravity machine part 3 if you'd like.
You got that, did you? Okay. It's a noisy thing. I had, oh wait now. What's my file? I found it now. If we can just get back in here now, it'll be fine.
What happened?
He's helped me out, he's shown them that while I got sorted out. Sorry. I've done them already.
I'm bloody never in a tire in my life. Chocolate everywhere. You have no idea. I'm waiting for bed. Your water bottle beside your
Away you
bed.
go.
Okay. Well, Sandy, did you have some photos that you wanted to share for us, or?
See what I can do.
There we go.
This was my first idea. Oh. Basic man standing there, holding the bricks, spinning the bricks at the angle I wanted them to go to. That was my first machine. I can't move it on now. Oh, good. What have I done again now? I've done something stupid again. Can you see that?
So I can see the thumbnails in your photo manager.
I'll have to, yeah.
There we go. And I can see your mouse cursor as well.
Should have put them straight up and down. I'm in the right hash of this.
There we go.
Right, and if we can get down with this now. Right, that was my first machine. That was it down at Imperial College. That's Eric Laithwaite standing behind it. That is the first Australian machine for the lab test. That's the one in the box that was set up to get the correct running parameters for the test machine. That was the patent. That's the two guys. He was a co-director of APEC, actually, John Simmons. He did the test. That was the result of the test. A series of 20 identical tests were conducted on this gyroscopic machine. Quickly goes, the force bias was non-zero for all 20 tests. The average force bias generated accounted to 2% of the highest force peaks. And that was the book. And that's a machine you just showed just now at rest with a spring on it. This machine here was a much better version of that anti-gravity 3. It's never been shown, designed to show everything from basics, from zero hub speed, from zero gyro speed. It'll show you everything that gyro will do under these accelerated conditions. It's fully instrumented. It's telemetry, all telemetry. Even they're not fitted yet, but there's two little strain gauges fitted under each side, and the outputs came out through this miniature rush gear. What do you call it? Forget what you call it now. The price of old age. They're all just more copies of the same thing. I've got hundreds and hundreds of machines, but I don't want to bore you with them. That was the old machine and new machine together. It's replacement. That's the replacement. That's another view of the replacement. That's about it, Tim. I'm sorry about that. I made a mess of that lot.
Oh no, that's wonderful. Yeah, I'm just wondering, do you have more that you'd like to show us, or
I've got hundreds, but I'll leave it just now. I'll sort them out so that they can be a bit more intelligible.
Oh, okay. Well, if you'd like, we could go to our Q&A session.
Yeah, if you could do that, please.
Okay. Yes, sir.
I'm sorry about that. I'm dreadfully sorry. I had my little granddaughter showing me what to do, and I must have done something she told me not to do.
Oh, no worries at all. I just genuinely appreciate you presenting this for us and showing us all of these things.